In this video, we're going to look at solving simultaneous equations when we have got three unknowns. Typically, they will be x, y, and z, but it could be any other variable, a, b, and c. Okay, so first of all, it says we have three unknowns. Then we will need three different equations to solve for each variable. So we want to reduce them to two variables by the elimination or the substitution method, and then solve. So basically, we're going to start with three equations. And let's just look at our equations first of all and see if they're okay. The first equation, you've got 4x plus 3y minus z is equal to 5. Call that ... equation 1. If you look at your second equation, it's a bit awkward just because it's written as the y term first. So let's just rearrange the second equation. And we're just going to write it as x plus 5y plus 3z is equal to minus 3. And that is your equation 2. And your last one is absolutely fine, so you can just write it as your equation 3. ... equation 3. Okay, pick something to eliminate. So you can pick anything to eliminate here. There isn't really one term that stands out at me as being easier to eliminate. Sometimes there is. Sometimes there's an easier thing to eliminate. Or sometimes one of the equations is missing one of the unknowns or one of the variables. So say one of the equations is missing a y, then it definitely would be easier to get rid of the y's from the other pair of equations. Okay, but in this case, we've got x's, y's, and z's in every equation, so there's no obvious thing for us to get rid of. So here, I'm just going to say eliminate x. So ELIM-X, and this keeps me right. Lets me remember what am I actually doing, focuses my mind. I'm trying to eliminate my x. Okay, so to eliminate the x's, I need to get the same number of x's in two pairs of equations. So I'm going to use my equation 2 and my equation 1 here. So I need to have 4x's in both equations. So the first thing I need to do, and see this is the first thing I'm writing down, is I'm doing 4 times my equation 2. So I'm multiplying, it's not very clear, I'm multiplying my equation 2 by 4. Multiplying my equation 2 by 4. So if I multiply my equation 2 by 4, I will get 4x plus 20y plus 12z. And this is a bit that people forget. You also have to multiply the right-hand side of it as well. So the right-hand side of it was minus 3, so that becomes minus 12. And again, that was my 4 times my equation 2. We will then write our equation 1 underneath it, which was 4x plus 3y minus z is equal to 5, and that was my equation 1. So remember, and again, this is why we have written down our eliminate x. It focuses us on what we're actually trying to eliminate. We're trying to eliminate our x. The signs of the thing that we're trying to eliminate are the same. If the signs are the same, you subtract. So we'll just write down subtract. And 4x minus 4x is 0. 20y minus 3y will be 17y. Not a particularly nice number. Doesn't mean it's not going to work out nice for us in the answer. It might not. And then 12z minus z becomes 12z plus z, which becomes 13z. And then you've got minus 12 minus 5, which works out to be minus 17. Give this thing a name, and the name we're going to give that is equation 4. So our equation 4 contains just y's and z's. So we want to find another equation, which we're going to call equation 5, and we want it to have y's and z's as well. So I'm going to eliminate my x's from equations 2 and 3. So I'm going to multiply my equation 2. It's going to get multiplied by 3, which would give me 3x plus 15y plus 9z is equal to minus 9. And that was, as I've written down, that was my 3 times my equation 2. Then we'll write down our equation 3, which was 3x minus 4y plus 2z is equal to 10. That was my equation 3. And again, it happens to be that they're both positive again. And I can then subtract to get my equation 5. So if I subtract, you've got to have 3x minus 3x, which is 0. 15y minus 4y, which is going to be 15y plus 4y, which is going to be 19y. And then you're going to have 9z minus 2z, which is going to be plus 7z. And then minus 9 minus 10, which is going to be minus 19. So dot, 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 that is my equation 5. Okay, so we're just going to write our equation 4 underneath our equation 5 so we have them together, and then we can see how we might tackle this problem from here. It's not going to be a particularly nice question, just because the numbers are very awkward, but we need to get the same number of, either the same number of y's in both equations or the same number of z's in both equations. So I think we're going to go for the z's, just as the numbers are slightly smaller. So I'm going to say eliminate z. So I'm going to say to eliminate my z. So I'm going to do that first of all. I'm going to multiply my equation 5 by 13. So 13 times my equation 5. And I'm going to multiply my equation 4 by 7. So that means I will have the same number of z's in both equations. So when I do that, I will get 247y plus 91z is equal to minus 247. That's for my 13 times my equation 5. And for my other one, I'm going to get 19y plus 91z is equal to minus 119. So that was for 7 times my equation 4. Okay, next bit then, what we want to do is just subtract again. In this case, they have all been subtracted, that's just by chance. And if you subtract, you're going to get 128y is equal to minus 128. Okay, so it looks like it's going to work out nicely. So your y divide across by the 128, y equals minus 1. Okay, we have a fair bit to get squeezed in here. What we want to do then is sub that into equation 4. So you could have used 4 or 5. I've decided to use 4. And you're going to get minus 17 plus 13z is equal to minus 17. And with a bit of working out, I'm going to get my z is equal to 0. So I've skipped that working out to save us a wee bit of space. My z is equal to 0. And then we're just going to then sub that back in. So you've got your equation, you've got your value of z, you've got your value of y. All we're left to do is find your value of x. So I'm going to sub it back into one of the original equations. So I'm going to sub back into equation 1. So if I sub that back into equation 1, I'm going to have 4x, because my first equation was 4x plus 3y minus z is equal to 5. So that would become 4x minus 3 minus 0 is equal to 5. Wee bit of working out, that's going to give me 4x equals 8, and that will give me x is equal to 2. So you found your 3 values. You can check them in equation 2 or 3, so you can do that just to check, and you will see it does work. So your answer, x is equal to 2, y is equal to minus 1, and z is equal to 0. In this example, it says the curve y is equal to ax squared plus bx plus c passes through the points 1, 6, 2, 20, minus 1, minus 4. Evaluate a, b, and c and write down the equation of the curve. Okay, and it gives you a hint. Start by creating 3 equations. In an exam, I don't think you would get that hint. So we just have to look at this. So what we're going to do is we're going to sub in the coordinates. So the first coordinate is a point that passes through 1, 6. And if you sub that in, you're going to have, sub 1, 6 into the curve. And if you do that, you're going to get 6 for my y value is equal to a times 1 squared, which is just going to be a, b times 1, which is just going to be b, and just c, and that's what we've got. So that is my equation 1. I'm then going to sub in my next point, which is 2 20. So that means your x value is 2, your y value is 20. So 20 is equal to a times 2 squared. 2 squared is 4, so 4a. B times 2, so just 2b, plus your c, and that's your equation 2. And then we're going to sub in your last point, which is minus 1, minus 4. Now take care in this one. This is where people will make mistakes. Minus 4 is equal to a times minus 1 squared. Now minus 1 squared is where people will make mistakes. Minus 1 times minus 1 is plus 1, so that's just a. And then it's going to be b times the minus 1, so it's just minus b, and then plus your c, and that's your equation 3. Okay, so we're going to decide to eliminate our c. Our reasoning for eliminating our c is that it's going to be easiest because you have the same coefficient of c, which means there's a 1 in front of the c in every equation. There's one c in every equation. That makes it much easier to eliminate. So just say eliminate c, keep yourself right. And how I'm going to do that is I'm going to use my equation 2 minus my equation 1 first of all. Because if you look at your c's again, they're both positive. If the signs are the same, you subtract. And so it's equation 2 minus equation 1. So 20 minus 6 is going to be 14. And then you've got 4a in your equation 2. You've got 1a in your equation 1. 4a minus 1a is going to be 3a. And 2b minus b is just b. And c minus c is just 0. So that's what you've got. So that was 2 times equation 1. And of course, we're going to give that another name. We're going to call that equation 4. Okay. We're also going to use our equation 1 and 3 would be a good one to use. You could have used 2 and 3 as well, but 1 and 3, if I use 1 and 3, it's going to make life really, really easy for me. So I'm going to do equation 3 minus equation 1. So equation 3, we've got minus 4. Equation 1, we've got 6. Minus 4 minus 6 is going to be minus 10. And then you've got, in looking at the a's, you've got a in equation 3. You've got a in equation 1. A minus a is 0. Brilliant. And then you've got minus b minus another b is going to be minus 2b. So, and obviously your c minus your c, they disappear. So we've got down to one unknown, one variable. This happens quite often. If you look at the questions and you really think, right, take a wee bit of time, 10 seconds even, just to think, right, is there going to be an easier way for me to do this? And quite often there is. There's an easier way of doing it. So a wee bit of working out here, you're going to get your b is equal to 5. Okay, so put it in a wee box. Once you've got your, can you just call that one equation 5? Not that we really need it. Once we've got your b, you can then just say sub that back into equation 4. Sub that back into equation 4. You're going to have 14 is equal to 3a plus 5. A wee bit of working out, that's going to give you 9 is equal to 3a, which gives me, squeezing this in here, a is equal to 3. So I've got my b is 5 and I've got my a is equal to 3 so far. And of course, what you're left to do then, we're just going to say we are going to sub into equation 1. So we're going to fire that into equation 1. Equation 1 was 6 is equal to a, which we know is 3, plus b, which we know is 5, plus c, which means 6 is equal to 8 plus c, which means minus 2 is equal to c, or c is equal to minus 2. The question said for us to find the equation, so we'll need to rewrite the equation. I didn't do my check in the last example, and just to show you can check, so we'll just say check in. We've used equation 1, so we can't use equation 1. We'll check in equation 2. So equation 2 said 20 is equal to 4 times my a, which is 3, plus 2 times my b, which was 5, plus my c, which is minus 2. Let's just check. 4 times the 3 would be 12, plus 2 times the 5 is 10. 12 plus 10 is 22, minus a 2 is 20, so that works. So my answer, I know, evaluate a, b, and c and write down the equation of the curve. So we can say a is equal to 3, b is equal to 5, c is equal to minus 2, and the curve is y is equal to 3x squared plus 5x minus 2, and that is us done.